shall we get started, Ian, do you think? Yes? Okay, that looked like a positive nod. A thumbs up would be good too.
Yeah, yeah.
Okay, then. Okay, welcome everyone to the latest holophon workshop, the intro to the Nano Sense Arduino. Thank you to multiplay.ca for funding these workshops that we're presenting here. And because we are a Regina-based organization, we would like to acknowledge that the land on which we gather is Treaty 4 land, traditional territory of the Saulteaux, Cree, Dakota, Lakota, and Nakota peoples, as well as the homeland of the Métis. So now I'll introduce Ian Campbell. Ian Campbell is a filmmaker and multimedia artist who works in video, installation, and performance art. His short films have been screened across Canada at film and experimental media festivals such as Festival du Nouveau Cinéma in Montreal, Windex in Winnipeg, Antimatter in Victoria, 8Fest in Toronto, and others in Europe and the US. He has presented performance work live using improvised projected video as an artist at artist-run centers and performance venues across Western Canada. He is currently based in Regina, Saskatchewan, where he teaches film at the University of Regina. I guess that's about it. We should probably let Ian do his thing. Thank you, Ian.
Thanks, Ernie. Can everybody hear me? Okay, yeah. Okay, thank you. I'm just going to share my screen here. So, can you guys see my screen, or what are you seeing here? You can see my PowerPoint?
Yeah, I'm seeing that.
Okay. Oh, it's weird. It doesn't have it usually has the green line around the edge. It's not showing up this time. Huh. If you would like to look at this PowerPoint, you can look here at the link. You should be able to download it off of our Google Drive. The purpose of this workshop is a brief introduction to the Arduino, what it can be used for. It'll give you enough information so you can decide if you want to continue to part 2 of the workshop. So that's on May 4th. I'm going to switch my camera here because okay, now can you see my desk? My hands? Yes? Okay. So yeah, if you want to drag that line between the two, the screen sharing and then the video, you can make either one bigger or smaller, depending on what you need. So what is an Arduino? Basically, the Arduino is a microcontroller. So a microcontroller is like a tiny, teeny little computer. They're much lower power than regular computers, like the laptop or desktop that you're using right now, which means it doesn't require as much electricity to run, which is good for a lot of the projects that people use Arduinos for. But the downside is it can only handle really basic things. So I put some examples there. It can count time, it can make simple decisions, it can create patterns, store very small amounts of data. And the microcontroller itself is this little black square there. It's made by a company called Atmel, and they've been making these kind of chips for many years. But at sometime in the sort of mid to early 2000s, someone came up with the idea of the Arduino. It was a couple of guys in Italy. It's basically taking the Atmel microcontroller family, and there's a whole bunch of different chips, and putting them in a form that is kind of makes them much easier to use by hobbyists. So the Arduino is a microcontroller, but it's also like a kind of a framework for making use of the microcontroller, and that includes both the hardware part of things, or the wires and things that you can plug into it, as well as the software side of things, which is like libraries that we'll use, or the code that we'll use. So I was gonna show you a bunch of different versions of the Arduino. That one there, that's called the Mega, and it basically, each Arduino kind of has a sort of slight differences that make it easier to use for certain things. The Mega is like a sort of a monster in that it has a lot of lines. The lines, which you can see, these sort of little black plastic connectors here, each go into a different line of the microcontroller, and you can see this one's quite a large one with lots of little tiny sort of fingers on it. If you look over here on the slide, each one of these lines either has a description on it, TX, RX, GND, or a number. And there's basically, each line has a different function to it. So when you have a Mega, you have a lot more lines, a lot more things you can do with it. Here's a couple. These are kind of like the standard size Arduinos. When they first came out, they developed this size. And this one's called a Leonardo, and this one's called an Uno. And they look fairly similar. You can see that all Arduinos pretty much have some way of connecting them to a computer. So this USB connector here, this is also a USB connector, it's just a smaller type. And then they usually have a power adapter. So these are places where you can plug your power in. And it makes it so that the Arduino can kind of play on its own. It's great that you can plug it into a computer to program it. You can run, basically the USB can power the Arduino as well as providing communications. And but the nice thing is you can also run the Arduino by itself. It doesn't need a computer plugged into it, because this little microcontroller can kind of keep running after you've applied, as long as you've applied power either here or here. Those are some of the bigger ones. A couple of years ago, they started getting a little bit smaller. So this one's called a Nano, and that one's called a Micro. So they're basically different sizes for different purposes. These ones seem to be, they're cheaper. They can fit them into smaller places. So if you're trying to build a certain size, you know, this is a great alternative. And then this one is kind of like a version where they got rid of the whole USB part of it. So this little thing on the end is the USB connector, and this one just doesn't have it. So you use a different way of communicating with that board. If you were to get really small, you could just use the chip. So that's like that's an Atmel microcontroller, and it's just the chip. It's just the there's nothing really to it. There's nothing to connect to. So you'd have to sort of build, you know, all of the capacity of these kind of boards around this chip. But you could still upload this exact same program. If it was simple enough, you could upload the exact same program on any of these. So they're really flexible and great to kind of play with. Now, how do you make them do anything interesting? Well, usually you have to buy peripherals. So peripherals are different little boards that do different things. So this is a teeny tiny MP3 player with this little card is what you would store your MP3s on. This one is for controlling motors, so stepper motors. A lot of the 3D printers around, especially the open source ones, use these one of these chips, or actually 4 of these, and then 1 of these with the code written into it. This is an accelerometer. So that would measure the angle that this particular chip was sort of held at, or how fast it's moving in space. That's a Bluetooth, so you can add Bluetooth capability. This is like a little clock, so you put a battery in there and it would be like a little tiny, it would keep time. This is a display, so it's like a little LCD display, and this is called a shield, and shields are made to fit into the Arduino, so you can plug this directly in and like program it. It's actually a little touch screen display. This is another shield, which is a motor controller. It's usually designed for robotics. So you can, if you have a little hobby robot, you can connect this up, and it will run a whole bunch of different types of motors. And you can also make your own shields. This is one I made, which is just basically, it's got some pins here that would plug into it, and then you've got this. This is like a proximity sensor. So it'll allow you to, if you put your hand in front of it, it would tell you how far away that your hand is from this sensor. So this is all like kind of fun to kind of like work with if you have the skills. And I, of course, I mean, I've been playing with Arduinos for a long time, so I do have developed a lot of the little kind of skills of like soldering and that kind of thing that are required to put together a project. Here's just an example project. This is basically the accelerometer here. It's on a kind of a flexible little wire. I've got a little tiny motor, which is actually a tiny water pump. So inside here, there's some little fins that spin around, and that's connected to this green wire here, and that goes into the. This is a motor controller, so you can control two. You can control 2 motors. Basically, Arduinos generally can't handle a lot of current, or they can't drive like high current devices like electric motors, or larger lights or LEDs, that kind of thing. But you can always add extra amplification of the power by just adding a little board like this. And then instead of plugging it into a USB, I just have this little adapter, which I've just wired directly into it. So this one is basically has a little 4-digit display, and then that display is sort of representing the orientation of this little chip. So you can kind of, it's not like exactly degrees or anything exactly like that. It's kind of a little messier than that, but it's basically giving me data about where how this chip moves in space. And I was using this with a plant to sort of track its movement. So I was trying to use the pump to supply it with water. So it was kind of like 2 things were happening. This was just feeding back the information to the display, and then every 12 hours or so, this motor would go off for a couple of seconds. Probably the least sort of accurate or reliable part of this project is the pump. These things always get jammed up and they never work properly. But the actual chips work quite well, and they don't. You know, you can run these for a long time and they won't break down or anything like that. I'm going to try to get up and close to this thing here so you can see. I think that's in focus. So that, you can see there where it says Nano, that's the Arduino. And so I've attached all of these little wires to run to different parts of this device. So you pretty much always have to have power cables running to each part of the like you have to supply power to the digits, you have to supply power to the motor controller. So a lot of this is just running the same power to a whole bunch of things, but it kind of requires a bit of you know, engineering to figure out how to do that, how to do all of that stuff. A little bit of soldering skills and just generally kind of planning and all that stuff. The whole thing is in a little 3D printed caddy, this black part. So these things just fit inside. So they kind of like live inside there. If we go back to the PowerPoint, this is a plan showing one of the Arduinos. So this is the Uno, but you could pretty much, I could probably come up with some references for the peripherals after. It took me a while. You see, most of this stuff I bought sort of, mostly I buy a lot of stuff on eBay, and it's a lot of, it's kind of all over the place. There's not like, you know, one distributor kind of thing. But I'll try to come up with some references. Generally, and if anybody has any questions, you can definitely just stop me on the mic or type it in the chat out there. This is kind of like a plan of Arduinos that you'll find online. If you just type in like Arduino Uno, and you'll find like these kind of plans. It's basically a pinout. It tells you what each pin does to a degree, I guess. So the black ones are kind of more functional. They're basically power, different types of power. So there's like there's a couple of different voltages that are used. 3.3 and 5 are the main ones, and then if you're running other, you know, higher amperage kind of devices like motors, you might use 12 or higher. This is all DC, so it's direct current, so it's very safe. So I could just touch, you know, I could just touch all of this stuff in here, and I'm not going to get electrocuted. It's like less than a 9-volt battery kind of in power. There's 3 on here that I'll sort of point out that are probably the most important. So digital, you can see that digital, all of these blue lines, which is basically every line, you have the opportunity to use as a digital signal. So that means you could basically turn it on and off like a switch. All of the pins can be used as either inputs or outputs. You have to choose one. So you can't use them for both at the same time, but you can choose any number to be inputs and any number to be outputs. The ones that are marked green are also can be used for analog. So analog means that the difference between digital and analog is basically a digital signal is just either 0 volts or 5 volts. So that corresponds to 0 and 1, like in a computer. Whereas an analog pin can be used for a whole variety of a variety of voltages from, you know, 0 to 5, and it will give you a whole bunch of numbers. So analogs are really good for working with kind of like the real world, for sensing the real world. Like for instance, a light sensor is a great example of an analog, the use of an analog input. So that's why they put an A here in front of the number, because they're used a lot in a lot of Arduino projects. And then the one other one that I might point out is the PWM. And those are these red dots. So only some of the pins can be used for PWM. And you can think of PWM as analog output. So the green ones are analog input. So that means that we're feeding information, or we're feeding a tiny, tiny electric current into the Arduino. And PWM is the opposite. We're feeding a voltage out. So you can use the PWM to change the brightness of an LED. So you can make it brighter or dimmer. You could change the speed of a motor. Those are the primary kind of ways to use PWM. But you'll find pinouts like this for pretty much all of the Arduino boards, and they're really helpful when you're just kind of like figuring out. So here's some steps that I would use for developing a project. Like say you want to sort of get into the Arduino. First of all, have an idea. That's always very important. Having the idea is kind of like looking around at what other people are doing and trying to figure out what sort of little job you need done, whether it's something artistic or something practical. Research your hardware. So you figure out what Arduino you need and what other peripherals or what materials you need. Find a library. So a library is a set of code that is used with your hardware. So it might be used for communicating with a certain sensor, or it might be used for one of the shields that I showed you. But you want to try to find a library so that you can make use of that thing. You don't really want to invent everything yourself. A lot of working with Arduino in the programming aspect of things is what you're kind of piecing together, patching together ideas that other people have already come up with. I find that's kind of the best way to kind of work in terms of working with the Arduino. Forward put it together, so you're actually building it, and then look at example code and modify. So every library will come with example code, so you can kind of like you make use of that. You do need a little bit of syntax, like in terms of learning languages. Working with the Arduino it's not like learning a language, a human language exactly. It's more like you're kind of like piecing together things, understanding a little bit of syntax, understanding how to deal with error messages. But it's not like you just start typing away at the beginning, kind of. But that's something we'll go into more in part 2, I think. So here's the idea. So let's just use this as a case study, kind of. I want my Arduino to measure how an object moves and gives me data in degrees. So I do my research. I find there's a thing called fritzing. You'll find diagrams like this all over the internet, and they're kind of like schematics, but the fritzing is just a kind of a picture that you can see that people can design. It's a little bit like a CAD program, and they design how things fit together. And so it makes for beginners, it makes things a lot easier because you can kind of see you got different colored wires and how they fit together, kind of. So that's a fritzing diagram for this for an Uno, and then this little guy here. What you want to do is you want to research the library so that you have access to the information. So this is called the BNO005. That's basically just this guy here. It's made by a company called Adafruit, which makes a lot of different chips that are very useful. And basically, it takes a lot of the it makes these particular components much more functional because it's doing a lot of the math for us. So it's bringing the information out in a much more usable form than if we just like bought these components and tried to put them together ourselves. But this device, you know, it goes really nicely with this library that the company has made, and so I've installed it in my Arduino editor kind of thing. Then you've got to put it together, and there's lots of different ways to put it together. You can see that I put it together by soldering things together and then using some of these jumper cables. You can also use something like this. This is like a proto board. Each one of these little holes is connected electronically, so you can like attach things together. You can plug things in. You can like fit things onto the board and then run different cables from one side to the other, or from one device to another device, that kind of thing. So you could use your fritzing diagram to put together your physical object. And then the last step is look at example code and modify. So you would take the code that's the example pieces, and you would just kind of play around with it and try to get it to do what you want to do. So as long as you have, you know, enough sort of information or knowledge, you can start to decode some of this information and start to use it to your kind of advantage. This is for the next workshop, we'll be digging into this particular example and figuring out a little bit more of what it's doing. I always think of Arduinos as glue. I think of them as things that fit other things together, or ways of getting information to go from one place to another, kind of. Arduinos are kind of like a translator for a lot of my projects. You know, it's not that I use the Arduino specifically to do, you know, a certain job in terms of audio or video or other sort of computer stuff, because they just don't have the capability to do that. They don't have, you know, you can't really run full motion video on a small chip like this. It's not really possible. There's other options to play around with, like Raspberry Pis and stuff like that, if you're interested in that. But they're more like fitting together like a project. So something like this. This is an example that I'm working on right now. So this is a time-lapse project, and I've got these cameras here are taking pictures of this tomato plant growing, and this is how I'm using the Arduino. So I've got two of them in this project. So one is they're both plugged into this Mac Mini, which you can see down here. And the Mac Mini is running a piece of software, which I'm not really going to go into right now, but it's like it's a way of recording. I can record sound and I can send signals. And what it's doing is it's the accelerometer is attached to the plant, so that when the plant moves, it sends the signal through the Arduino. And then the only way to get it from the Arduino into the software that's running on the Mac is to connect it and to have it communicate. So that's the first way that this Arduino is glue. It's allowing me to attach the sensor to the software in the computer. And then the second way, and this is kind of like an input. So we're kind of getting input from this through this Arduino. The other one is more like an output, and basically the Mac Mini is sending a signal to this second completely different Arduino, which has a little infrared LED on it, and the infrared LED can send a signal to the camera, and it's basically as if the Arduino is just pushing a button on a remote control. And so the only way to kind of get this camera to do anything, like it doesn't have a, it doesn't have any way to communicate with it. You can't plug the USB port in and just send it commands or anything like that. So the only way to do that is to use the glue of this Arduino to send it a command as if it was, someone pushing a button. And in this way, and I've been using this sort of setup for quite a while, but it allows me to do all my time-lapse photography, to make my time-lapse videos in a much more flexible way than typical intervalometers, which are the devices that usually photographers use to do time-lapse. So it gives me the ability to program this any way I want. I could have a time, like I could have a delay of like days or weeks if I wanted to. And I can use it in all kinds of different cameras because of this. The infrared codes are available online for a lot of different cameras, so I can switch out to different cameras and retain the functionality of this sort of system. So that's kind of why I refer to them as glue. Now for this upcoming workshop, so part 2 of this workshop is about this particular Arduino. So this is the Nano Sense BLE. Let me get the name right here. Arduino Nano 33 BLE. And I think that's actually Sense. I think it's Sense after there, but they've got a couple of these new, these are sort of new. I would say they're only a few months old. Maybe, I think they came out maybe in December last year, but they're quite new. They've come out with some really new boards. And when I saw it, I thought it would make a really good workshop. So these are the things that you need if you want to participate in the next workshop. You're going to need a computer, Mac or Windows. I'm generally using Mac for all of my stuff. I have used the Arduino. This is the IDE. So this is the programming editor basically. And I've used it on Windows, and it works pretty much the same. You can also get it for Linux. But some kind of a computer, you can download this software from arduino.cc, and it's all of it is free, the software side of it. You'll need to buy the Nano 33, and you're going to need a USB micro cable as well. So now, why did I choose the Nano 33? This is one of the, I think it's the first Arduino that has built-in sensors. So it's hard to see on here, but some of these little black rectangles on here, they're actually little tiny sensors. And so if you look at this little diagram here, so the red one is color, brightness, proximity, and gesture. So this is basically a kind of a fancy light sensor. It's not a camera, so it's not going to be able to give you images, but it's going to be able to give you some kind of data in terms of these things. Now, I think some of these things are kind of vague. I don't know what gesture is. I haven't experimented with it enough, but it's interesting. Color, I think, will be fairly straightforward, but again, I have to experiment a lot more with these things to tell you more about them. But it's something that we can do in the workshop as well. The blue one is the digital microphone. Now, I don't think that this particular device has the ability to record and playback sound in the way that you might expect from a computer these days. But I would say that it would be something that you could use for just sensing that there's a sound in a room, say. Motion, vibration, orientation. So that's kind of what I've been showing you with other chips. It just has something similar on here. Temperature, humidity, and pressure. Again, I haven't played with these ones yet either, but there's like a little thermometer that we can use for making measurements. I don't know how accurate they're going to be. I don't know if accuracy is something that is going to be that much of a goal. I think it's mostly just getting information and seeing what you can do with it. And the way that I'm kind of treat this particular project is how can we use this as a sensor to feed into another piece of software that will be doing sound. So, how can we use this to control a synthesizer, for instance, would be one question that I would have to see what we can do. How can we take the sensor data and turn it into MIDI data, which could go to, any number of, pieces of software. Here's the pinout for this particular device. So you can see there's the A. So it's got 7 or 8 audio inputs. All of these other ones, so all the orange ones are digital as well. But the nice thing about this particular one is we don't have to buy any peripherals to kind of play around with the sensor. So I'm not really going to use any of the pins. We're just going to use this as is. In sort of this is what I would like to kind of play with in terms of like interfacing this device to something else. And I'm not sure exactly what software is going to work the best. I'm trying to find something that's going to be open source or free or a trial version, and something that is going to work on Windows and Mac. So stay tuned for that. Does anybody have any questions? Any questions so far? Okay, right now I think what I'll do is I'll just I'm just going to show you the programming. So this is the IDE. So this is the editor that we use for programming the Arduino. Right now, this particular Arduino has a program running in it. So let's just take a look at what the program is telling us. So up here it says serial monitor. So I could turn that one on. And this is the information that the chip is sending out. And if you watch the numbers, you'll see that they change depending on how I'm moving this thing. Yeah, and it's not super easy to see what's happening. So a couple of years ago, they added this other thing called the serial plotter, which makes things a little easier to see. So instead of seeing them as numbers, we're seeing them on a graph. So you can see that if I move it, I could get spikes based on this particular program is just running the gyroscope in here just to see, orientation of this thing. So I can kind of like turn it around and I can see how the graph changes depending on how this is moving. So ideally, we could take this information and we could send it to a synthesizer, and we could play around with building a tool or an instrument that uses this as the basis. Let's load another program onto it. This is the most common, easy to use test program that are used in the Arduino. It's called Blink. And so what's going to happen is I'm going to upload, well, first of all, I'm going to compile this program. And then I'm going to upload it. So the program itself is basically, if we look at this little section here, we've got something called a void setup and a void loop. And void setup is basically just something that runs once. And all this is going to do is it's going to set up this pin so that it tells the Arduino which pin we're going to use. And every Arduino has a built-in LED or a little tiny light. And then we're going to, and like I said, this runs once. And then this loop will just run forever. And it's basically just saying, we're going to send a high signal, which is 5 volts, to this LED. Then we're going to wait for 1,000 milliseconds. Then we're going to send a low signal, which is 0 volts, to the LED. We're basically turning it off. And then we'll wait another 1,000 milliseconds. And so it's just a super simple test program. So what I do is I just click this here to compile it. Wait for a second. And it's building the code. It's basically machine code that will go into the Atmel chip and it will run. Looks like there's usually when you see orange here, it means there's a little bit of an error message here, but it also compiled when you get this text here. It tells you how much of the memory or how much of the program space and how much of the memory it's going to use. You can think of the program space as like the hard drive, and then the memory is like your RAM. So it says done compiling. So then we click this arrow here and we're going to upload it. So you might see some little blinking happening over here. We'll see. So basically what I'm doing is I'm replacing the program that was in there with this blink. So it's going to go down here, uploading, and then it tells us how quickly it's happening. See that yellow light's blinking? And it says it's done. And do you see that yellow light there? That's the program that's running. It's a very, very simple program. But you have to do this kind of stuff just to make sure that things are working. Every Arduino has this program in it to begin with. Like they run it, they put it in as a test in the factory, and then when you first plug it in, you'll see that the light is blinking. And then it just tells us that it's working. So when we do the workshop in May, we'll have to go through some testing, some figure out if this stuff is going to work. We'll go through the different examples. So if you go up into your IDE and you look under examples, examples are basically code that has been made by the people making the libraries. And if you go down here, this is for example one of the examples I used for my little code, my little project that I showed you before. And so I can bring up any of this stuff. I can bring up basically I would look through each one of these examples and I would just open it and see how the coding of this particular device happens and what I need to do to modify it enough just to give it my own, to get it to do what I want it to do. It looks kind of complicated right now, but a lot of times you can cut this down so that it's just doing a very simple thing, and it won't seem as complicated anymore. But you do have to kind of get into it and try to read through it and figure out what exactly each one of these things is doing. So examples for the Arduino BLE Nano 33. So there's examples for each one of the sensors. So we'll get into figuring out how to play with these and get them to do what we want. Let's just look at one of them and see. So it's not too much code. You can see that most of this is comments. So the stuff in gray is just, they're just telling you what this does. And the stuff in blue or red or black is the actual code. So at the top here, it's including the libraries that have to be in here. It's defining some variables. This is another defining like an array or something. Some sort of a serial number here. A lot of the stuff you wouldn't even touch. You just leave it alone. Here it's opening up the serial port. So this is how fast the serial port is going to go. It's setting up device names. It's color begin. That's probably important to start the whole process. Here it's just printing the word color. This is while. So while is a type of loop. Int is an integer, so that's a size of a number. If is an if statement, so that's making a decision. So if this variable central is true, then this it will go into this section here. This is a variable. Looks like the length of the color data, and then this is where it's actually getting the color data. And this is where it's printing what it got. So it's each one of these would be a different variable for red, green, and blue, and then some other intensity or some other variable. So it would hopefully it would print the color information. Let's try compiling this and see if it actually works. If anybody has any questions, just shoot. I've noticed that the compiling is much slower on these than on regular Arduinos. Yeah, I'm getting this because this chip is so new. Some of this stuff isn't working, and I'm not sure. I've seen this before. This right value is ambiguous, so I'm gonna have to work on this and see what's happening with that. A lot is going to change between now and May. A lot of this stuff is like constantly being updated and that kind of thing. So what I'll do is I'll have some examples that are working for you guys. Like the one that I use that works is this gesture. So the gyroscope is working really well. And that's the code that I had in at the beginning of this. Let's see if it comes out. Oh, looks like another warning. Still compiling though. No, it did compile. So it had a couple of little hiccups, but it seems like it's still working. So I'm going to upload that one. I'm going to switch back to my Oh, yeah, it's uploading. Oh, not available. It might be because I'm using a USB hub so that I can run all my other stuff on this computer. So I'll have to investigate that too. Sometimes when you have too many USB devices in, it's not great for the connection. Okay, so we're 5 minutes to 8. So that's pretty much all of my presentation for now. If you're interested and you want to experiment with this chip with the next workshop, well, I'm going to go back to my PowerPoint for a second here. So if you can see the PowerPoint, they have 3 different versions of this particular Arduino. One is the BLE. So BLE just means it's a kind of a Bluetooth. They all have Bluetooth. This is this little box here on the end. But this one is just Bluetooth. This one has the sensors, and then this is an Internet of Things version. I'm not really sure why that's different. Maybe some Ethernet connectivity or something. But the one that the one that I've got here, and the one that you should buy is the Sense one. Also, if you don't have one of these cables, make sure you get the right type of cable. So you need the micro version, which is kind of the flatter one, rather than the mini version. It doesn't come with a cable. So all it comes with is this little box with the, like all you get is the chip in it inside here on a little piece of foam. That's all you get. So you need to have your own cable, and probably you have one of these cables at home. If you want to buy these, you can buy it directly from the Arduino shop in the States. I bought mine at Robot Shop, which is just a Canadian, it's like a Montreal retailer where you can find this stuff. There is a version with headers, pins installed. Yes, there's 2 versions. So I don't think Robot Shop has it, but if you want to get one that doesn't have the pins, you can get that one, but otherwise it comes with the pins. So they're talking about these things here. So it's really easy to, like most of these devices, like this kind of thing come without the pins installed because it's easy to solder them on if you have a soldering iron and very delicate hands. But you can also get it without somewhere here. If you look on their site, you can find it. Yeah, so with headers. So I thought I saw that somewhere. Anyways. There's probably other retailers. If you have other retailers you want to check on, you can check them out. That's the end of this. So does anybody have any final questions before we wrap up? This is a teeny tiny screen that I got. It's really small. I have so many little tiny parts that I haven't even used yet. I just kind of buy them and then I just like forget about them, and then I have like boxes of these little parts. This is a tiny mini SD card reader. So you could store information on an SD card. This is a soil moisture sensor. So if you want to figure out how dry your houseplants are, you could use this to measure the resistance of the soil. Question, is it possible to use an Arduino simulator for the next presentation? Yeah, I guess so. I don't know if it would be much fun. Like the whole, what the idea of this is to use this as a sensor, right? So the fun part is like connecting this to something that we'll be able to like make sounds with, that kind of thing. So yeah, and also as long as the Arduino simulator has, is updated with this latest board, that would be important too. But I would encourage people, if you just want to come and observe the workshop, it's going to be pretty hands-on, so people can like just ask questions and get their troubleshooting kind of done. The sort of the idea of the workshop is just to kind of like learn stuff. So if you want to come, if you don't want to buy the board, that's fine. You can come and observe the workshop. That's no problem. So I don't see any other questions. So I think we could probably wrap up for tonight. Thank you to Ernie for introducing me. Thanks to Holophon and multiplay.ca. And I hope to see you again at one of our next workshops. The next workshop is next week, Tuesday, again, 7 o'clock. And it's all about reel-to-reel tape recorders and looping and stuff like that. So we're going way back into the olden times with analog and all the fun that can be had with analog stuff rather than
what's old is new again, apparently.
yeah, what's old is new again. Thank you, everybody. We'll see you later. Bye.